Good evening. So this evening I want us to go through um, just to go through the aptitude test that we had yesterday with those that were attempting the aptitude test. So the aptitude test was mainly designed to help out those that want to join us, that is for online lessons for free. So we had an aptitude test of which the top scholar was selected for free lessons. Why the aptitude test? Well, many might be interested in the online lessons, but of course we are interested in those that are serious with the studies and of course with the school. So that is the reason why we conduct the assessment before even allowing anyone to join us. That is for a free slot. But if you want to register with us, you can still register without a test. But if you are interested to join us for free, that is what we usually do. And of course, if you happen to be the top scholar, we are aware of the online test, the polarity that is there. It might be that you are getting the answers from Google or somewhere. So now what we do, you are required to maintain the high performance. Okay? Even as you join us, you pass the test, but you are required to maintain with a good performance. I think that way we can go up to until you write your exams. So this is the test that we had yesterday. And now this live broadcast, we are just going to go through and solve the multiple choice questions. The questions are from radioactivity, that is atomic physics, which is O-level topic. So that is where the questions are coming from. All the questions, the topic was atomic physics, which comprises of atomic structure and radioactivity. Okay, so the other thing that I would like to announce is that we have the free programs in the case of those that are not aware of our free programs. So some of the free programs that we have, one, we have the program for aptitude test. So the aptitude tests are carried out every Sunday. The topic is normally communicated. And this is just to choose those, to choose top scholars that become part of our learning platform, learning program for free. So always the top scholar is chosen. Then we have free lessons that are conducted on YouTube, like today, that is every day, 19 hours. Then we have also the newly introduced program for biology essay competition writing. So this is the program designed just to help you how you can navigate or how you can answer. That is section B of biology paper 2, and that is essay questions. This is where majority, or this is where biology becomes challenging. Biology is simple, but when it comes to essay writing, quite a number of people have challenges. And this program, we hope it is going to help, just to help out on how you can do your essays. So also this is the competition that will be happening every Wednesday, and the topic will be announced. Now for the entry for this one, so like I said, the platform that we use for communication and posting of the tests is the Telegram. So if you join our Telegram, that is for free. If you join the Telegram, every Wednesday I'll be posting the topic. Every Wednesday I'll be posting the questions from a specific topic. Then you answer the question, then I'll be marking, and of course give you the feedback, the weakness that you might have, where you need to improve and all that. So we hope this one is going to help. So also the time, you need to take note of the time. So for aptitude test on Sunday, 20 hours. Also, you have to join the Telegram group for you to be part of the program. If you feel that you are that who deserve free lessons, then for free lesson, that is 19 hours every day. Then biology essay competition, which starts Wednesday, 20 hours. Okay. So this down part is just to explain the importance of these tests. I mean the importance of this program. So for aptitude test, just to help us to select the best student to join our online lesson for free. Then of course, when it comes to the lessons on YouTube, and this is also to help out those that are revising. Yeah, just to help out. And of course, in addition to that, we have a lot of video upload. Then we have the biology essay competition. I think for me, this one, I just want to help out learners to, I think, how to know how to handle this part of biology. It's quite a difficult part to many, but of course, I'm ready to go for this one so that we can change the narrative. I think that is the main reason for this. So this is just meant to help learners perfect their writing skills in biology and be able to handle paper 2 section B questions without difficulties. So those from other countries could be a different arrangement, but I'm sure the standard is that in biology at some point we all write essay questions even at university level, and where it becomes difficult is how to go about it. So all that I'll be able to break it down, and we should be able to see an improvement and of course change in mindset in terms of biology essay questions. All right, so we can go into it and look at the questions that were there in a test. So I hope you have a calculator with you. So the first question, let us see the first question. So the paper was comprised of 2 sections. So the first section, which contained the first section, 10 marks, and there were 10 questions. That is multiple choice. Okay, so let us see if we can answer. Let us see if we can answer the first question. So for the first question here is that which of the following radioactive emission has the strongest ionization effect? So we've started. The first question is that which of the following has the strongest ionization effect? By the way, the highest in this paper got 83, and of course the second highest got 82. So please, if it was you, how were you going to answer this one? Okay, so this one, Jackson Chumba is saying, okay, sir. Then we have Wiengo Marvin, sir, I'm willing to write the aptitude test. What should I do? Okay. All right. So please, if you're willing to write the aptitude test, I think check to my community there. I gave the link to, okay, I'll give the line that you can WhatsApp at the end of it if you want to be part of those that will be writing aptitude tests. Okay, so which of the following radioactive emission has the strongest ionization effect? So you have A, X-ray, B, we have gamma ray, then C, we have beta, and of course D, we have alpha. So which one has the strongest ionization effect? So these two things, normally people confuse them. Don't confuse the ionization effect. Don't confuse ionization effect and penetration power. I think these should be differentiated. Okay, so the type of radiation that are produced are just the 3. So I have gamma, alpha, and beta. Gamma has the strongest penetrating power. Okay, penetrating power has the strongest penetrating power or effect compared to the 3. So followed by beta. So this one is the second in terms of what? Penetration power. Then the least penetrating power, or the least with the penetrating power, or the least one is what? Is alpha. Okay, I hope you be able to, or you know this. But for ionization power, the strongest is alpha. Okay, so alpha is the strongest in terms of ionization power, but the weakest in terms of penetrating power. So the answer here is D. So D is the answer. Okay, I wish I could go on explaining this part. Then for the second question is that the half-life of the isotope X is 4 days and its initial mass is 2 milligram. What mass of the isotope X will remain after 12 days? So I've just realized that this one, the answers have not done some editing, but we are going to solve the question as it is, ignoring the what? The multiple choice answers. Okay? So if you have a calculator with you, we should be able to punch together and of course find the answer to the question. So now, how do we deal with the question here? So we are given that it has the the half-life of, or the half-life of the isotope X is 4 days. So you can take note of the data. To make it easy for you to handle the question, take note of the data. So half-life, you can use small letter t with a half, which is equals to what? 4 days. We are given is 4 days. Its initial mass, so initial mass you can write n with a naught, n with a small zero there as a subscript, then 2 milligram, that is the initial mass. What mass of the isotope X will remain? So for the mass that remains, you just put n. So this is the mass that remains. So it's the one that we are looking for. After 12 days, okay, so after the period had passed, after the time passed, 12 days, so you represent that one with capital letter T, the amount of time that elapsed or the period that passed. So you're given that is 12 days. Okay, so now what do we do? So you should be aware of this formula, that is sample that remains divide the initial equal to half, then n. Okay, where n is equals to the time that elapsed divide half-life. So these are the formulas that you need. So now for us to find the sample that remains, we need this one. But before using this one, we need to find n. What is our n there? Okay, here we are given the period that elapsed 12 and the half-life 4. So we're going to say 12 divide a 4, which is a 3. So I'll bring this one this side. We are going to have n, we don't know. The initial mass here is 2, okay, equal to half to the power what? That is half to the power 3. Now, if you have such, you know that is 1 over 2 to the power 3. 1 to the power 3, 2 to the power 3. This gives us n over 2 equal to 1 over 8. So this one, if we were to cross multiply, to be 8n equal to a 2. Divide 8. So n is going to give us 1 over 4, which is 0.25 milligrams. So this is the mass that remains after a period of 12 days. So like I said, from the multiple choice, we are going to ignore the multiple choice answers, and of course go with our solving. Okay, so that's some error in typing, and this one was a free mark. I saw it late, so I couldn't change it. Okay, so Jackson is saying not clear. What is not clear? Is it the audio or is it the board? Kindly confirm what is not clear before we proceed to look at the other part. But from the screen, I can see is really clear. So anyone who is facing problem with the audio, are you able to get me? Someone to confirm quickly, please. We proceed with the second question. What is not clear? Jackson, come through, please, and confirm what is not clear. Or maybe is you saying you've not understood? Okay. So there's a question, am I audible? So be able to answer. If I am, then we can proceed. Okay, so Marvin saying yes sir, the audio, yes sir, the audio is clear. Okay. All right, so let us look at the second one, or the third question I mean. So nuclear of this, okay, with mass number, you know that if you have something like this, the top part is the mass number and the down part is the atomic number or proton number. So that decays by emitting 2 alpha particles. So 2 alpha particles and 1 beta particle. What is the composition of the resulting nucleus? What is the composition of the resulting nucleus? Now here, I would give you the general reaction when it emits 1 alpha particle. So the general, if you have X as the nuclide, the parent one, it decays by emitting an alpha particle. You need to know that if this is the mass number, this is atomic number, the mass number reduces by 4, the atomic number reduces by 2 to form the resulting nuclide. Okay? Then plus helium, which is the alpha. Okay, so that is the general reaction. Now here we are told that it emitted how many? It emitted 2 alpha particle. So which means the mass we are going to look at reducing by 8, then this one by 4. Okay, so from this original one we are going to subtract 288 minus 8. We are going to have what? We are going to have 280. Okay, we are going to have 280. Okay, then the atomic number we are going to have 82. The atomic number we are going to have 82. Then now it emitted 1 beta particle. You know that 1 beta particle, it is, if you have the mass number, the atomic number, emitting a beta particle, the mass remains the same, but the atomic number adds 1, plus an electron with mass 0, and of course a charge of negative. So from here now, we are going to add a 1 there. So for the mass, for the atomic number, we are going to have 83. So it's going to be, in short, these two, if we are to join them now, the resulting will be Y 288, then 86, then how is it going to be? So let me put X, so it's going to be 280, then here it's going to be 83, plus 4 H2, then here there are 2 of them, so you can put a 2 in front, then plus a beta particle. Okay, so something like that. Then now the question that you are given here is what is the composition? So number of protons. So number of protons is this one. This one is called the proton number, so it should be 83. So already we have seen here the one, this is 84, this is, so already we know that D is the what? Is the answer. But if we are to go further to calculate, you know that the proton number will be what? 83, and you know that the proton number is equals to electron. Okay, the proton number is equals to what? Electrons. So also electrons will be what? 83. But what about neutrons? How do you find neutrons? So we're going to use this one, which is the Z plus N equal to A, which is atomic number or proton number plus neutron number should give you the mass number. So what is the atomic number? 83 equal to, plus neutron equal to 280. So it is going to be, N is going to be 280 minus 83. So please, can you kindly confirm if it is going to give you 197? Otherwise, that is how you work it out. So that is what we needed to do in order to find this answer. So the answer here is what? Is D. Okay, let me check if there is no anyone with a problem here. Do we have a problem, please, up to this point? Okay, sir, what is not clear is the camera. Try to adjust it, please. Okay, so Marvin, what happened normally is that because here I'm casting my screen, which means I'm sharing my screen. So what you can do, go on settings, just here on top of, I don't know if that is available yet, but it could be the settings. The way you do if you are watching the video on YouTube in low quality, I'm sure you're able to control the quality by placing on the settings. We have 144, it starts from 144, 360 and all that. Try to do that. I'm sure it should be able to give you a clear view. Otherwise, even after the class, you're going to find that the video that will remain as a recording will be very clear. So just try to do that. Could be the challenges could be on your side and the network, the strength of the network that you are using. Okay. So now let us look at this fourth question. Which of the following equations shows the nuclear fission reaction? Now, nuclear fission is just a splitting of the large nuclei into the smaller ones by the neutron bombardment. Okay, that is what we call nuclear fission. So fission means splitting, and normally uranium is split into smaller ones, barium and krypton. Okay, but the key thing here is what? Uranium. So the one that shows nuclear fission automatically, you are going to go where there's uranium. Okay, why not B? B is nuclear fusion. Okay, because we have smaller nuclei forming the large one. Look at this, hydrogen and hydrogen combining, forming what? The helium. This one should have been helium. Okay, so this is the fusion, nuclear fusion. Then for this one, it normally split into two, but this one just splitting into one plus energy, making this one wrong. Also the last one, it cannot split into one. Okay, and here there's gamma produced. What is produced in the nuclear fission is the energy. So this one being the best answer here. I guess you've gotten that. Okay, then for the fifth question, which one of the following travels a straight line? Okay, which one of the following travels in a straight line across the magnetic field? So even if it was electric field, magnetic field, there's only one that travel on the straight line. Okay, there's only one that travel on the straight line, even if it was magnetic field and also okay, Marvin is saying alpha. I don't know which question. I think it's the question that we've passed already. Okay, I guess it's the first question. Now, Marvin, what is the answer to the fifth question? Which one of the following travel in a straight line across the magnetic field? Which one? Okay, so gamma. That is good. So gamma is the one that travel in a straight line. Even in electric field, is the one that travel in a straight line. Now, what do you think is the one that travel? What is the reason why you are saying travel in a straight line? Do you know the reason why it is not diffracted by in both magnetic and electric field? You can just type in if at all you are able to get me. Give a reason why you are saying gamma. Why gamma? Why not beta? Why not alpha? And maybe here, if we are to put it, let's say this was the source and this is electric field. Okay, uniform electric field here. Let's say this is the negative side. Okay, and this is the positive side. Okay, this is the positive side. I think that is a question that we are going to look at some point, but I thought of explaining it. Maybe we are not going to meet to reach there. So if you have a source coming out like that, then we say this is A, this is B, this is C. Would you be able to identify what is A, B, and C in terms of the radiation that are given Well, that is something that you need to look at, okay, or something that you need to know. So the answer here, therefore, is gamma rays. Then when it comes to question 6, the radioactive element thorium, which is 234-90, with a half-life of 24 decays by emitting a beta particle, how long will it take for 1 gram of thorium to decay to half or 1/8 the mass? Okay, how long will it take? So let us look at the data. So I encourage you, every time you're given such a question, make sure you put out the data so that you don't confuse the thing. So half-life is given as 24 days. Then now, how long will it take for the 1 gram? How long will it take for 1 gram? So the initial mass, which means is what? 1 gram. Okay, to go to decay up to, okay, so which means the one that remains, should we say the one that remains? Okay, so this one is just a ratio in short, to decay up to, okay, so I'll say ratio of the initial, the sample that remains and the initial is equals 1/8. So which means here we are going to put 1/8 of the mass. What do we do? What do we do? Okay, so here let us look at maybe one way that we can do it. So one way we can deal with this question is to put this sample remains over the initial amount, the ratio 1/8 equal to 1/2. Then do we have okay, I think that way it will take us time because we need to calculate n and all that. Okay, what about if we were to say 1, let us look at number of half-life. Let us find the number of half-lives by using, because here we are going to find, look at the way it is, we are using number of sample that remains, divide the initial, half over 2, 1/2 n. There are different ways that we can find n. We can find n by putting up 1/8 here equal to 1/2 right there to the power n. This is the 1/8 divide 1/8. Okay, whatever you find here, it should be 0.025. Then you apply log of 1/8, whatever you find, that is log 8, log 10. Then also here you apply log of 0.5, n in front. Then you find n by dividing log 0.5, divide log 0.5. You should be able to find n. Okay, then when you find n, you can replace it there. Then of course you can find whatever you want to find. But let us look at the easiest way, because here we are told how long, which means we need the period. Okay, this, we need the capital letter T. How long? Okay, so to find the capital T, we need to multiply number of half-life, multiply T. You know that the half-life is 24. We already have it, days, but n we do not have it. There's a simple way you can find it. Okay, so a simple way you can find it is start dividing this until you reach 1/8. So this is going to give us a 0.5 here. Okay, well, let me just say 1/2. Then 1/2 divide 1/2, it is going to give us 1/4. Then 1/4 divide 1/2, it is going to, or divide half, is going to give us 1/8. So you count how many half-life, 1, 2, 3 for you to reach here. So n is equals to 3. Then you are going to replace it here. So 3 multiply 24, and this should be able to give us 72. Can you kindly confirm if it's giving us 72 days? And therefore the answer here is the D one. Okay, so Marvin is saying the reason is that it has a high penetrating power because the gamma radiation is very dangerous to human body. No, 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 no. That is not the reason why it is not diffracted, Marvin. The reason because it has no charge. Okay, the reason because it has no charge. Gamma radiation has no charge, and therefore it is not diffracted by either magnetic or um, electric field. Okay, so we've just given the characteristics of a gamma radiation. So I guess you'll be able to get what I said. Then question 7. The following can be used to detect alpha particles, beta particles, and gamma radiation or gamma rays. So all these can be used to detect these three. We have photographic film, we have diffusion cloud chamber, we have GM tube, which is a Geiger-Müller counter, however you pronounce it. Then we have the spark counter. Now they are saying which one of above or which one of the above cannot be used to detect beta and gamma rays. Now, if you were to give the one that cannot be used to detect gamma and beta, beta and gamma rays, you need to look at the one that uses high ionization power, because these two have low ionization power. And now when you look at the instrument or the detecting machines that are used, or the detectors, you should be able to choose the one that is best for alpha, in short. Okay, and that one, which means it involves the use of high ionization effect. So the answer here is spark counter. So please, if you have a different answer, be able to bring it and explain it why you think spark counter might not be the answer. Otherwise, we are going for spark counter because it involves the use of high penetrating high ionization effect, and that is what alpha does. Which of the above cannot be used to detect beta and gamma rays? So in this case, we are saying 4. Okay? Which of the following cannot be used to detect gamma and beta rays? So 4. Then a radioactive source which has a half-life of 1 hour gives a count rate of 100 counts per second at the start of an experiment and 25 count per second at the end. How long in hours did this experiment take? So I think what you need to understand is the language that is used. So like always, collect the data. So let me just put up the data right here. So what data do we have here? A radioactive source has the half-life of 1 hour. So half-life here is equals to what? 1 hour. It gives the count rate of 100 count per second at the start. So initial count. So this NO is initial activity or initial mass. So 100. Okay, I'll put C count per what? Per second, something like that. I'm just putting it for the sake of correcting the data. And at the start of an experiment and 25 count per second at the end. So the one that remains now, which is n, just n, it is equals to what? 25. Okay, count per second. How long in hours? So we are looking at how long in terms of period it will take, which is capital letter T. And for us to find capital letter T, we multiply number of half-lives multiplied by the what? The half-life. That is how we find the capital letter T. Okay. So now what we need, half-life, we already have it, is 1 hour. What we need is the number of half-lives. Okay, so Jackson is also saying that the view is not clear. The view is not clear. Okay, so please, I guided at first. If you have a way of going to the setting and of course try to increase your quality, you should be able to get it clear. But if it's not, which means it is due to network, but afterward you can come for the recording, should be able to find the clear one, and you can control the quality. Okay, I don't think I have a way of doing that because this is live session. So please, if you can stay with me and now you come back at the end, I really appreciate. I guess that one should be able to work. All right, back to the question. So for us to find capital letter T, I said you need n. Okay, number of half-lives. How do you find number of half-lives? So this is how you do it. So you just look at the initial, you keep on dividing it by a 2 until you reach the ending part. Look at what is here. The initial is 100 and the final is what? 25. So you put them like that. Then you continue dividing by 2. So 2, what are you going to have? A 50. Divided 2, what are you going to have? A 20. Okay, you're going to have a 25. So just something like that. So which means you have how many half-lives? 1, 2. Okay, half-life is just the time taken for half of the activity or for half of the mass of the sample to reduce, or for the mass of the sample to reduce to half of its original. Okay, that is half-life. So here we have 2 half-lives. So number of half-lives, which is n, is equals to what? A 2. So just get the initial, then you divide it, but don't go beyond what you are given at the end. And this works only when you have the initial and the final. Okay, so just divide it 2, it takes you to 50, you divide it 2, and finally it takes you to what? To 25. You cannot go beyond 25 because this is what remained. Now, how many half-lives? You can count these spaces, 1, 2. So number of half-lives is 2. So to solve this question now, we are going to say t is equals to a 2 multiplied by half-life is 1. So is 2, is it in hours? Okay, so 2 hours. So that is the answer to this. So which is B. Then for question 9, a radioactive material gives a count rate of 8,000. Let me check. Maybe there's a way that I can do this. Okay, maybe there's a way I could control this. So uploading one, playing. Okay. Well, I'm not able to see whatever I can place. Okay. All right. What about the question 9? A radioactive material gives a count rate of 8,000 count per minute. After 20 days, it count rate. After 20 days, it gives a count rate of 500 count per minute. What is the half-life of the material? So from the formula from the formula N equal to T over half-life. So to find half-life, we are going just to make T the subject, this the subject of formula. And it's going to be half-life equal to the time elapsed divide number of half-lives. This is what you need. So now from what we are given, can we find the time elapsed? And the time elapsed is given after. So a radioactive material count rate from 8,000 to 500. Okay? In 20 days. So time elapsed was 20 days. Okay? Then now we are saying we need to find number of half-lives. How do you find it? I've shown you how to find the half-life, number of half-lives if you are given the initial and the sample that remains. Just keep on dividing by 2. So divide 2, it gives what? 4,000. Divide 2, it gives what? 2,000. Divide 2, it gives us what? 1,000. Divide by 2, it gives us finally 500. Okay, so how many half-lives are here? So you can count 1, 2, 3, 4. Okay, or 1, 2, 3, 4. So number of half-lives is equals to what? A 4. Okay. Then the time period elapsed is 20. So half-life is equals to what? 20 divide a 4, which gives us 5. Is it in days? 5 days. So the answer here, it is C. Finally, question 10. The radium has a half-life of 1,600 years. Okay. Calculate the number of half-lives. Calculate the number of half-lives it will undergo for 100 gram mass to reduce to 12.5. Calculate the number of half-lives. So this time around, you are calculating the small letter n. The small letter n here. We can use this formula, period over half-life. But are we given the half-life? Yes, we are given, which is 1,600. Are we given the number of half-lives? No. Okay, so for us to find number of half-lives, we are going to use the simple one. So 100 gram. Then the remaining one, I can put it here, 12.5 gram. Okay. Okay. So I'm watching people's comment. I should be able to respond to you if you are in class. So that is what I'm basically doing. I'm teaching as well as watching. Okay, so the camera is not clear. I don't know what is happening to this camera thing. The camera is not clear. File reported. Stop streaming. I'm trying to see how I can control it. Is it clear now, please? Because I'm able to see it clearly. Is it clear? Tish Smith, have you tried to look at your settings? Because there's where we can control the quality of the video. Sometimes the quality will be due to your network. But I believe that the recorded clear one should be able to remain after I'm done calculating. So that is what I'm trying to experiment as well. Am I going to have, or are we going to have a video after I'm done? That is what I'm trying to experiment. So I will be able to end on this question. Then we can see afterward if the camera remains clear, so that next time we come, we'll be able to know that indeed afterward it becomes clear. Okay, so how do we find the number of half-lives? So like I said, if you have the initial and the one that remains, you just divide it. So divide this one by 2. It is going to give you what? A 50. Divide 50 by 2 should be able to give you what? 25. Divide 25 by 2 and should be able to arrive finally there. Okay? So now, how many half-lives do you have? 1, 2, 3. So number of half-lives is equals to what? 3. Okay? So Tish is saying it's clear now. I guess tell us what you've done for it to be clear. Did it just become clear on its own? Could be the network that we are using or that you are using. Okay, so the number of half-lives is what? Is 3. And therefore the answer is 3. That was how, that is what you needed to do to answer that question. Okay, so what are we going to look at next time? So this is just a part 1. So the other part is section B, where we are going to answer. So these are the questions that were there. Let me just reflect them. In the case you start watching the video, you should be able to answer them in advance, so that next time we meet, you are going to answer them. So these were the questions for section B. Very nice, very sweet, and yeah, they were very simple. So next time we are going to, okay, there's another question. Okay, so this was one of the questions that was there as well. Very sweet question, very sweet question. Okay, so please, this was the test that they were writing as the aptitude test. So the next one, we are having genetics. those that love biology, genetics will be on Sunday. That is the one that we're having this time around. So we're having biology, but of course remember on Wednesday we have the essay competition. You should be able to join that. So please, in the case also you are interested to join our online lessons, where we can now you can get now to learn more. You can WhatsApp the number 096 097 09 I mean 26 0976, okay, 0976402563. So those that wanted to join the Telegram group for the competitions, this is the number that you can still WhatsApp. So 0976402563. So when you WhatsApp, please, sometimes I tend to have a lot of messages and all that to handle. So be specific, okay? Be specific, go direct to the point. I'm interested in the free competition program. I'll be able to send you the link and you'll be able to join, and of course updates will be given from there. So if you are interested, please, this is the number that you can WhatsApp. And also if you are interested to join us for the online lessons, they are ongoing. Those that are writing GCE next year, those that are also writing ECZ September, I mean, is it November? I think you're starting 4th of November and all that. And even those that are doing IGCSE, Cambridge, GCSE, and also we have other examination boards. So you should be able also to join. You can also join for lessons, okay? So please, each subject or the subject that I offer, we have mathematics, we have physics, we have biology, we have chemistry, we have civic education, we have ADMA. So each subject here, as they appear here, is 100 kwacha per month if you are registering only for one subject. But if you are registering for 2 subjects and above, is 85 kwacha per month. So this can take you a long way. Remember, what seems to be expensive now, it is going to be more expensive in the case you fail. Failing is going to be more expensive than what you can sacrifice now, because one, you'd have wasted your time, and two, you're going to start from the scratch. And in the case of tuitions, you're not just going to do it for a month, you have to do it maybe for a year. So that would be costly. So starting now is the only way, and you have to do it in school once and for all. So please, in the case of those that are rewriting next year, also it becomes challenging when you start lessons in the end or last minute. There's a high chance that you are not going to make it, because how can you do things that you studied in 3 years in 1 month? Others, they even come the night before. I don't know how, I don't know the miracle that they expect, but that is disadvantaging yourself, and it is costly, because at that particular time you're desperate. So it's the right time to start preparing. Otherwise, see you in the next one.